1.4 TSI running rough at cam sensor code, and we suspect the timing is out. So as to get to this timing cover and get it off, to get to the timing chain, we've got to remove all these boost hoses. I need to also go down the back to take the tensioner off of the supercharger drive pulley. So I'm going to get this off and start getting some of these ancillaries out of the way, and then we'll catch up then. So as usual, we've got all the auxiliary components out of the way. Coolant bottle is completely removed as we can't work around it. A charcoal filter just moved to one side, and we're ready to get the engine mount off. So as you can see, I've got the belt detensioned, ready to remove, so we can start pulling the crank pulley and whatnot off. We've got to remove quite a few bits and pieces to get this timing cover off. As you can see, the water pump drive for the supercharger is up here, and we've got to actually remove that to access some of the bolts too. So you can see I've removed this roller up here. There's no belt roller now, and I've also unbolted the boost hose off of all of its mounts. There's 3 mounting points, one here, one round the back here, and one up on the top. Obviously we're going to have to remove this to get all of timing case off when we look from above, because we've got to get the belt off of the supercharger. So that is driven off of this, the water pump here, and there's actually a clutch here between these two pieces that's electromagnetically controlled. And as you can see, there's that belt there that's actually the pulley for the supercharger is right here. So to get this timing case cover off, we've actually got to remove this water pump, and there is 3 bolts holding it. There's one at the bottom here, a Torx 30 you can just see here, and there's 2 each side of the top. So as we can see, I've got the engine mount now removed. We need obviously the access, and we've also got the water pump dropped out, as you can see. So there we've got the water pump completely out the hole. See the belt that drives the supercharger, and we can see the supercharger pulley and then the tensioner for the supercharger. Now we can see the bolts that are hidden by the water pump being in place. So I've also got the alternator unbolted as it goes through the timing cover and sandwiches the timing cover. So we've got all our ancillaries off out of the way. As you can see, the alternator's out of the way. We've got our water pump off, and our belt's just hanging on the supercharger. And I'm now just running around undoing all the bolts that surround the timing case. Basically, I've got this breather pipe off, so anything that connects this timing case to the block and to the sump will be coming off. These are the structural ones for obviously the engine mount, because this is taking the weight of the engine through the timing case with the engine mount bracket. So we'll get those 16s as well. As you can see, here's the LG engine code. Yeah, so we'll need to get that crank pulley off down there. We might have to have the tensioner out of the way, and we will be good to take this off. So here we have our timing tools. We have a tool for locking the camshafts, tool for locking the crank, for measuring TDC and the spark plug hole, DTI gauge to go into the top of this unit. We just screw this bolt tool into the back of the engine block that we'll show you in a moment, where that 8mm Allen key headed bolt is. We screw that in just before TDC, and then when we turn the engine over, as it hits TDC, it hits again, the crank hits against the end of this bolt and it locks at TDC, so you can then no longer turn it forwards. This is also the bolt that is used for when you tighten and torque the crank bolt pulley. Unfortunately you can't undo it with this. You actually need to counter hold the crank pulley to be able to undo the bolt. So we now need to insert our timing tool in to lock the crankshaft, and this 8mm Allen key that is just above us here is where our tool will screw in and push against the web of the crankshaft. So to be able to put the timing tools in and lock the camshafts on this 1.4 TSI engine, we need to remove these plates from the rear of the head. As you can see, we're at number 4 cylinder, and we've got these rear of head plates that you can actually see the back of the cams in, and there's 2 of them. There's this one big one here, and there's this smaller one here. On the later models they are made of plastic, but same thing, same deal, and the plate that fits in there looks like this, and as you can see, it's got these two lugs, and they simply just push into the back of the cams and lock the cams in place. This is just a bolt hole, so when the cover is off, this bolt hole here, where this bolt is, can be put back in and keep that locked into the head and keep it located. And there's just a tool number if you need to buy one, basically. But very simple in its operation, and quite fine to be able to get it to fit into the head going that way around. So these are going to end up at lower positions, not at the higher positions. So this one, so if you were to look from the back, you want them to be like down here, almost pointing to a 45-degree angle downwards to the center. So we have our plug in the back of the our bolt into the back of the hole in the block, and we've turned the engine over until it stops. And our camshafts, be difficult to show, but our camshafts are out of time. That should be pointing down at a 45-degree angle when it's pretty much horizontal, and this one is pointing down too much, so that actually the cams have gone past where they should be. So yeah, looks like the timing is out on this thing. So as you can see, we've got our crank pulley off, and all the bolts for the timing cover are now off also. We've got the bolts out of the sump, so we're ready to remove this timing cover. So the timing cover is off, and our timing has been confirmed to be out of time. Like we saw before, I had the bolt in at the bottom to get the thing TDC, and our bar at the back would not fit in because the cams are in the wrong place. So now I've got the cams in the right place, and I can get the plate in, and now I'm not near my TDC point. So what I'm going to do, because I've got the cams locked, they're in the right place now, I'm going to loosen the bolts that need to come out anyway, and then once they're loose I will turn the crankshaft around to TDC, and we'll see how far we go until we get to that point. Just a note to make about these cam pulleys. The pulley with the variator on the left for the intake cam, that bolt is a reverse thread, so we have to actually tighten the bolt or turn it clockwise to undo it. This one is a regular bolt, and we turn it anti-clockwise to undo it. So again, clockwise to undo the inlet cam shaft, to undo the variator, and to have the chain loose. So we should now be able to rotate these a little bit. So those are now free to move on the cams, and we'll then turn the crank and just get it to our TDC point. So that's now locked. I'm going to, my DTI gauge is now at this point. I'm going to zero it just to make sure we are at the right point. We haven't got more to our TDC. So we now are at our correct TDC on cylinder 4 and obviously cylinder 1. They are both in alignment with one another. And as you saw, I undid these to turn the engine, and we rotated a good amount of degrees to get the crank back to TDC. So these cams were quite well out, so we found our problem. The problem, like we say, with this design, the problem is that this tensioner doesn't have any form of mechanical locking element. As you can see, look how close these chains are to one another. Just about get my finger squeezed there between the two guides. So when we crank this engine cold starting and whatnot, and the tension of the valve springs onto the camshafts, the chain gets tensioned and untensioned on the actual tensioner side, and what can happen is it can push the piston back and push the oil out of it, and if this doesn't retain oil well, or it's leaking between the tensioner body and the actual piston and it's losing its retention of oil, it will just push that back and it will jump on the cams, and that's what I think has happened here. We do have a stretched timing chain, so because this chain is stretched, the tensioner is coming out an excessive amount, so there's just so much more tolerance here that wouldn't normally be here if this wasn't a stretched chain. So the reason why it's jumping is the stretched chain, and we obviously are going to replace our tensioner at the same time. So I've actually pinned the tensioner in the detention position, as you can see here, and look how much we can actually move this chain. So that's what's happening when you're starting the car. It's able to, as the load of the valve springs is forcing the cam lobes, as the engine's rotating, it's pushing this back and compressing the oil and pushing the oil out, and like I say, either leaking between the body and the piston or just back through its oil passages until oil pressure is built up, and this is the slack that we end up, and this slack ends up coming up here. So obviously I've got these cams loose, but you can just imagine the amount of slack that's there, it will just lift and jump over the sprockets, and that's how we get a chain jump. So this is an inherent design flaw in regards to, well, the chain will stretch, it will wear, but unfortunately there is no locking element to this tensioner. Once the tensioner's out, it can be pushed back in. So yeah, I will compare the part numbers and just make sure there are different part numbers and see if there's any external differences visible. So we've got the chain just hanging on a straight pick, and the old chain is about 1 link longer. If I can get the camera to focus, yeah, it's about 1 link longer. They're laying over the top of each other now. Just look at the difference, the new chain on top of the old chain. New chain holds its form, the old chain just goes slack. New chain, not too much deflection. Compare this to the old chain now. Then we can see the deflection of our old used timing chain, which is quite clearly stretched, as we could see in its fitted position. So the new chain tensioner on the top and the old chain tensioner on the bottom. Different part numbers. New tensioner, new chain guides, and new chain. We've got a new crank seal, new crank bolt, cam bolts, and O-rings for the timing case cover. So we've got our new timing chain just sitting on the sprockets. New tensioner is bolted up, 10 Nm on those 2 bolts. You can already see such a bigger gap between the chains, and how small the gap is going to be that the tension is going to actually extend out. So I'm just going to get the torque setting for these 2 top bolts, and we'll torque those ones up. Again, this one is reverse thread, so we need a torque wrench that can do reverse thread, and they're not keyed, so they have to be torqued and new bolts used. So I've pulled the pin out of the new tensioner, and as you can see, it's barely coming out, probably 8 to 10 millimeters. We've got this nice big gap between the chains, showing how stretched that timing chain was that came off of it. So we're going to torque these 2 pulleys now. I've got the torque settings. This is one that goes to 40 Nm and then 90 degrees, left hand thread. And this one goes to 50 Nm plus 90 degrees. Now the way to do this is to do the Newton meter reading first. So we do 40 and then 50. And once we've done that, we'll rotate the engine over with no locking tools and just make sure our timing is correct, because we don't want to stretch these bolts until we know we are happy that the timing is correct, because doing that 90 degree of a rotation is actually stretching the bolt, so it gets it to its correct tightness, and it can only then be used once. So yeah, we'll torque those up now that we've got the tension on, and we'll rotate the engine over and recheck our timing. So that's our two cam bolts torqued up. Like I say, 40 on the multi-spline left hand thread one on the left there, and that 24mm hex on the right has been done to 50. So because there is no locators for the pulleys, we have to counter hold the pulleys so they don't slip when we're torquing these up. Same again when we stretch them, we need to counter hold the pulleys with a tool into the holes, you know, like a big bar coming off. And then we are not worried about our pulleys slipping relative to the camshafts then. Just gives you an example of rotating the engine clockwise. If there's no retention in that tensioner, or it can push it back, the oil that's retained in it will go against the stock. It won't jump if it's a new chain, if it's not a stretched chain. The reason the chain jumped and the reason why this thing was running rough is because it was a stretched chain. Note that we have no slack here anymore. Yeah, so it can, without any mechanical detent inside of here locking it, it can go all the way back without jumping. It just will jump if it's a stretched chain. So we've got TDC on the crank. We'll just check and try and get our tool back in. And as we'd expect, with it being at TDC and locked in the same position we tighten those bolts up, the tool just drops straight in to the cylinder head and into the groove into the camshaft, so we know our timing is correct. There we go, it is in. There we go, that is in. Well, it's fallen out, but there we go, that is in, and locking our camshafts in the correct position. So our cams are now good. I can now torque my bolts up the extra 90 degrees, left hand thread, remember, said it about 3 times now, but we'll do the 90 degrees on both with the counter hold tool again, and I'll just show you the counter hold tool that I'm using. You can use anything, you can put 2 bolts for a piece of flat steel if you want. So this is the counter hold tool I'm using, just so I can make sure the pulley sprocket stays still and the bolt turns, and that's it, and we don't get any slack in the chain. Like I say, you could just use a flat piece of metal with 2 bolts sticking out of it, but you need to hold the pulleys basically. So we've rotated the chain over now for another time, after we've done our stretching of the bolts with the counter hold of course, and we've got our bolt in and at the back against the crank. We're at our TDC point, and our cam pulley lock is, or our cam lock tool slides straight back in again. And as we notice, again mentioning about the amount that tensioner is actually sticking out is only less than 10mm, which is great. And we've got, that's tight now, we've got tension on the chain, it's not slack. So this is spot on. We're now ready to just clean up the gasket surface at the bottom here and give it a wipe down where the new gasket goes for the timing case, and we'll reassemble. So whilst cleaning the back of the timing cover, I noticed that one of the bolts has actually worked its way loose, so I'm going to check all of them and make sure they're all tight and give them a re-torque, but it's a bit worrying. On the breather system for the, yeah, on the back of the timing cover, this PCV is worked its way loose. So yeah, it's good to find it now. We've got that a successful fix. There is no fault codes now logged, and we are good to go. The car is running brilliant. So as you can see, the job is now finished, all back together, and the car is running fantastically. Nice smooth idle and no fault codes. One thing that's worth noting is to crank the engine over to build oil pressure, and let the engine idle for a while, just so any airlocks in the oil pressure system are cleared out before revving the engine.